Guys, welcome to my YouTube channel. You're watching ETA. Now, this is the channel whereby we bring you the best in maths, physics, and chemistry. Now, guys, if you have any question that you have and you want to share with the rest of the crew, or you want to share with me, please feel free to put it in the comments. Or if you want to send me an email, you can request an email in the comment section. I will attend to your problem. Now, guys, if you haven't subscribed, please do so. Please click the like button and also the notification button so that we can give you more content. Now, guys, without waste of time, I'm going to teach you guys a very interesting topic in chemistry. The rates of extents of reaction. The rates and extent of reaction. It is a very interesting topic, right? And extent the reaction. Now, I'm not gonna, you guys know what a reaction is. I'm not gonna talk about what a reaction is. So, I'm just gonna mention few important things to understand in this topic. So we need to understand what a heat of reaction is. The heat of reaction, this is the net change in energy of the system. During a reaction, right? Now, again, another term, spontaneous reaction. Spontaneous reaction, when there's enough energy to start a reaction. On their own. On their own, we mean when the reactants have enough energy to start the reaction. We call it a spontaneous reaction. When there's not enough energy to start a reaction, you need energy to start a reaction, and we call that a non-spontaneous reaction. And the other important thing that we have to talk about is the catalyst. Since we are talking about the action to start we're talking about the energy to start a reaction. We have a positive catalyst. Now, the catalyst, it provides a path required provides a path which I made a mistake. Provides a path which requires less energy on the reactants. In order for reactants to change to an activation complex. We're going to talk about an activation complex shortly. All right. Now, in activation complex, what we know is that the particles meaning the reactants are separated and tend to move and collide to form products. Okay, now an equation for the heat of reaction. The heat of reaction is given by the change in energy, which is the energy of the product minus the energy of the reactants. That makes sense, doesn't it? Okay. Now, we have two types of reactions. We have endothermic and exothermic reaction. I mean, endo means outside, means inside, and exo means outside. Exothermic. And thermic means temperature. Thermometer, for example, it has to do with temperature. Now, endothermic exothermic. Now, the change in energy is negative. It means the energy of the product is less than the energy of the reactants. Okay. And the temperature increase since this energy released to the atmosphere or to the environment. So there's more energy that is released from the bonds of the reactants when they are broken. So if this is the energy versus time graph, this is what we're gonna have. So the reactants have a certain energy in their bonds. So the bonds break and the reactants forms an activation complex. And here, the activation complex, let me use a different color. Activation complex, then the particles collide and they form the products. However, the energy within the chemicals, within the compounds formed, it is less because the energy is released to the environment. Now, this is a change in H. All right. Now, this is an exothermic reaction. Okay. Okay. Endothermic reaction, it should be the opposite. But what are the attributes? What we know is that the change in energy is positive. Okay, the temperature decreases. The temperature of the system, it decreases. So the graph will look like this. Okay, no, this is E, this is T. It will look like this. Activation complex, product. This is a change in energy. All right. Now, we also have a term, the rate of reaction. The rate of reaction. The rate of reaction, it is given by the change in the reactants, the concentration of the reactant over time. Over time is equal to the rate concentration of the products over time, right? Okay, what are the factors that affect the rate chemical reaction? A, factors that affect the rate of chemical reactions. First one, it is the nature of the reactants. I mean, magnesium for example, is highly reactive. Okay. Another factor, it is the concentration. Concentration. I mean, why does concentration increases the rate of reaction? It increases the rate of reaction because there's bigger surface area or for contact in order for the reaction to start. Then we have surface area of solids. Solids. Okay, what we know is that powder will react faster than solids. And also temperature. The more the temperature, the quicker the reaction. The higher the temperature, so the higher the temperature, the quicker the reaction. Since there's enough energy to break the bonds. Then lastly, the catalyst. I won't talk much about that one. Now we're gonna talk about so-called the collision theory. I'll talk about the collision theory. Collision theory. It states that particles are in perpetual random motion. During the reaction. However, effective collision leads to a chemical reaction. That's the collision theory. Now, this means that the particles need enough kinetic energy plus correct orientation of particles in order for them to react orientation. Okay, that's it. So now, to demonstrate what I was saying graphically, I'm actually gonna divide our board into two so that we have enough space. Okay. Okay, now guys, I'm gonna demonstrate what I'm saying graphically. Okay. Okay, that's what we have. Okay. If this is the number of particles. Okay. Let's say this is kinetic energy. Now, when there's zero kinetic energy, there's the number of particles that react is 0. Okay. Now, what we know is that there will be a lot of particles that have an average energy. This energy, we call it the most probable energy. Most energy. energy. No, most particles will have an average kinetic energy. However, there will be a small portion of particles that possesses the energy. Now, there's a cutoff energy. This one is the activation energy. This is the energy activation energy. Now, this is the energy needed to in order for the particles to start colliding effectively. And as you can see, the amount of particles is now small. And no, I couldn't explain properly what that point means. Okay, that point, it means that all the particles that you have in the jar of reactants, all of them possesses energy. There's no particles that does not have energy. Okay. Now, this is the effective reaction. Now, what happens if you change the temperature? Let's see. Okay. Okay. Now, this is for low temperature. Now we're talking about change in temperature, okay? For low temperature, and then if you increase the temperature, it means more molecules will have energy. Okay. For low temperature, you can see these are the amount of particles. But if you increase the temperature, more particles will react because there will be enough energy in order for the reactions to start. Let's see what happens if you increase the concentration. Okay, if you increase the concentration, okay, okay, temperature, okay. No, lower concentration. If you increase the concentration, it means there'll be more particles okay. This is the activation energy. So this is high concentration, this is low concentration. So for low concentration, this is what we have. We have less particles. But when there's high concentration, we have more particles that will effectively react. Then now, what happens if you put a catalyst? If you put a catalyst now, activation energy, you can call it whatever, without a catalyst. If you add a catalyst, it decreases the activation energy. It decreases the requirements of the energy that is needed for collision to start. So that means by doing so, there will be more particles to react. Now this is the new with catalyst. Catalyst. Okay. And you must note that all graphs, they pass through the origin. Meaning all particles have energy. Okay, another note that we must make is that the temperature change graphs have the same area, meaning the amount of particles didn't change. Sorry for that, meaning the amount of particles did not change. Okay. Now, how do we measure the rate in a laboratory setting? Now, how do we measure? Now, measuring rates, we can use the gas volume produced. We can use precipitation formation. Okay. We can use the change in color. And lastly, the change in mass. Change in mass, yes. Now, guys, that was it for today. Thank you guys for being part of this lesson. Guys, if you have problems, please feel free to ask me. I'm here for you guys. This year, I want to help the grade 12. And guys, if you have any question that you want to pose, please feel free. And you haven't subscribed or click the notification button, guys, please do so. I'm going to the next one.